Hello and welcome back. Today we'll be doing questions A, B, C and D from the 2022 British Physics Olympiad Round 1. Let's get started. Question A. A steel ball is thrown down with a speed of 3 meters per second onto a hard surface from a height of 2.0 meters. It retains 70% of its energy on each bounce. Calculate 1. The speed at which it hits the ground for the first time, and 2. The maximum height it reaches after the fourth bounce. B. A long-distance cyclist uses a cycle computer that is dual-powered. It has an internal battery and a solar panel. While the cyclist is riding in direct sunlight, the solar panel on the computer provides energy at a rate equal to 1/3 of the power consumption. If a fully charged cycle computer lasts 10 hours when riding at night, calculate how long a fully charged computer will run for in direct sunlight. C. Riding around a corner at 10 kilometers an hour, a cyclist leans over at an angle of 12 degrees to the vertical. At what angle would they lean over if they went around the corner at 15 kilometers per hour? D. Io and Europa are both moons of Jupiter. Europa takes twice as long as Io to complete an orbit. What is the ratio of the centripetal accelerations of Io and Europa, A Io to A Europa? You may use the result that for this gravitational system, omega squared r cubed is a constant, where omega is the angular velocity and r is the radius of the orbit. Pause the video now to have a think, and once you're ready, restart to see if you were correct. Let's get started with part A. For the first section, we'll use the equation v squared is equal to u squared plus 2as, since we already have u, a, and s. Substituting these numbers into the equation, we get that v is equal to the square root of 9 plus 4g, and therefore v is equal to 6.94 etc. meters per second, and this rounds to 6.9 meters per second to two significant figures. If you're following the official mark scheme, then you'll notice that the BPhO says that 7.0 meters per second is the correct answer, and in this case, they would be wrong. What the BPhO have done is that they have taken 6.946 etc. and rounded that to 7.0, which is a rounding error. For the example answer provided in that mark scheme, they would lose 1 mark. Now we'll move on to the second section. Here we'll use mgh is equal to half mv squared, and we will rearrange for h, which is equal to v squared over 2g. Substituting numbers, this gives that h is equal to 0.4587 etc. meters. Adding this to 2.0 meters and then multiplying by 0.7 to the power of 4 gives 0.590 etc. meters, and this rounds to 0.59 meters to two significant figures. Now we can move on to B. In this case, we can look at the amount of power that the solar panels are providing, and we'll see that the solar panels are providing 1/3 of the power. Therefore, only 1 minus 1/3 equals 2/3 of the power needs to come from the battery. Since 2/3 of the power now comes from the battery instead of all of the power, the new runtime is 10 hours over 2/3, which is equal to 15 hours. Now we can move on to C. Here we can draw the diagram, and we'll call the point at which the bike touches the ground P. Firstly, we can draw in the reaction force R and the friction force P, and also call the distance between P and the centre of mass H. At the centre of mass acts our weight, W equals mg, and also the force resulting from centripetal acceleration. Here we can now resolve moments about P. The weight gives a moment of mgh sine theta in the anti-clockwise direction, and the acceleration gives a moment of mv squared over r h cosine theta in the clockwise direction. Rearranging this, we can say that tangent of theta is proportional to v squared, and therefore tangent of theta 1 over tangent of theta 2 is equal to v1 squared over v2 squared. Therefore, we have that theta 1 is equal to the inverse tangent of 15 squared over 10 squared multiplied by tangent of 12 degrees, which gives 25.55 etc. degrees, and this rounds to 26 degrees to two significant figures. Now we can move on to D. Here I'm electing to use three relations that stick in my mind more than the one that the BPhO have recommended. However, the one that they recommend is equivalent to the third relation that I'm using here. Firstly, we'll start with the equation for centripetal force, and this is F is equal to mr omega squared. I've also remembered that omega is proportional to the reciprocal of time, and that r cubed is proportional to t squared. That is Kepler's third law. From here, in the first equation, we divide by m on both sides, and then we can replace omega squared by t to the negative 2 to get that a is proportional to r over t squared, and then using Kepler's third law, we can write this as a is proportional to t to the negative 4/3. We can now calculate a IO over a Europa. This is equivalent to t IO over t Europa to the negative 4/3, and this is equal to 2 to the 4/3, since t Europa is twice of t IO. Putting this into the calculator gives 2.519, which rounds to 2.52 to three significant figures. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.